Exercise 503 is about concavity and points of inflection. Now this video is just the basic theory on it. I'll do another video on examples. So firstly, let's just consider y equals x squared. So the first derivative is 2x, the second derivative is just 2. And you'll notice y equals x squared is concave up. Okay, it's always concave up. Consider y equals negative x squared. So the first derivative is negative 2x, the second derivative is negative 2, and that's what we call concave down. So basically, when the second derivative is positive, the function is concave up. When the second derivative is negative, the function is concave down. Now, concavity changes at a point of inflection. Sometimes we just use POI to stand for point of inflection when we're writing notes. So at a point of inflection, the second derivative is always going to be 0, but you have to be careful. The second derivative can be 0 other places as well. So if the second derivative is 0, it doesn't always guarantee that it's a point of inflection. To prove that it is a point of inflection, you must show that concavity changes. Here are some examples of some points of inflection. So this first one is a point of inflection. You can see to the left it's concave up. So just like a happy parabola, the second derivative is positive. Here it's concave down. So it's like it's part of a sad parabola. And so the second derivative is negative. So what we can see down here, at the point of inflection, concavity is 0. To the left, it's positive. It's like a happy parabola. And to the right, it's negative. Concavity has changed. Here it was positive, there it was negative. It is a point of inflection. Let's look at these two specific cases. This one's called a horizontal point of inflection. It's called that because the tangent is horizontal at that point. So because the tangent is horizontal, the first derivative, the gradient, is 0. It is a point of inflection because here it's concave down and here it's concave up. So the second derivative is also 0. To the left, it's like a part of a sad parabola. So the second derivative would be negative, concave down. At the point of inflection, the concavity is 0. There's no concavity right there. And to the right, it's like a happy parabola. It's concave up, so it's positive. Concavity has changed. It is a point of inflection. This one is a vertical point of inflection. So that was y equals x cubed. This is y equals the cube root of x. Now at that point, the first derivative, the gradient, it's undefined. The gradient's vertical. Now remember from the gradient formula, y2 minus y1 over x2 minus x1. My x2 minus x1, that point there and that point there, that would make 0. We can't divide by 0. So the first derivative is undefined. The second derivative is 0. Here it is concave up, it's like part of a happy parabola. Here it's concave down. So to the left, happy parabola, it's a positive second derivative. Point of inflection is 0. And to the right, like a part of a sad parabola, it's negative.